All right, so downwards, weight, and this is not an unknown. Oops, well, I don't want to do that. This is not an unknown force. They tell us that the box has a mass of 40 kilograms, so we'll know what this one is, but weight, mg. Is there any other force acting on our system? Normal force is touching the ground. There are a lot of people who left out the normal force, but there's no frictional force without a normal force. And of course, one more force, friction. All right. Coordinate system. Look, some of you guys, your drawings are a mess. It's hard to figure out what you're trying to intend for me to read. If your test is as messy as that quiz, you're probably not going to be able to earn many points. So I'm going to ask you to please consider that somebody has to grade your work. Just look at it. Can you see a flow, a reasoned flow of ideas there? Because if you can't, I couldn't either. I did my best. But I'm looking at just the picture. Is it clear, labeled well, drawn with the ruler? Now, I'm going to use this as my coordinate system. It's aligned with the ground, but it's also aligned with the direction of the acceleration. And I'm going to say this is my positive x direction, and this is my positive y direction. I see one force that has to be resolved. So I'm going to resolve this one into 150 cosine 20, 150 sine 20. Any questions there? All right. I wanted to see a clear net force in the x direction equals ma, net force in the y direction equals 0 kind of formulation. In the x direction, I have just two forces, 150 cosine 20 minus friction equals ma. In the y direction, there's three forces, two of them up, one of them down. So normal plus 150 sine 20 minus mg equals 0. Now, it generates the relationships. With these relationships, we want to figure out the acceleration. So these are the relationships that are developed. I'm probably going to combine that with what I know about how friction works. Friction's it's a proportion of the normal force. We did substitution yesterday to get one relationship, but you don't have to do it that way. There are easier ways to do it. I can figure out the normal force. I know all the things. So I can say the normal force equals 40 times 10 minus 150 sine 20. Right, that's going to give me a number. So 400 minus, I don't know what 150 sine 20 is, but 51.3. So my normal force is 348.7. That means my frictional force, which is 0.3 times the normal force, is 105 newtons. So just going to sub it in here. So 150 cosine 20 minus 105 equals 40 times A. And this is where you get 0.9 meters per second squared. I'm not about to say that this stuff is easy. It is not. But what I am saying is that there's a procedure. Study the procedure. And when you get to your algebra, look, the algebra is the least interesting part, but you're going to have to be able to do algebra. It's just a part of what we have to do. All right. Let's see. We're on regular schedule, so I have quite a bit of time. I want to talk to you about something else today. We're going to set up a lab, and I want to talk to you about what the lab's going to be, okay? We won't have time to execute the lab, so we'll do the lab first few minutes of class tomorrow. The lab takes about 25 minutes to complete. It's not a particularly hard lab. Some of you have done this lab before. So you guys who have done this lab before, it's just the same thing. We're not changing it very much. But I want what I'm looking for, and this is what I was expecting to see on your paper. You push a 50 kilogram box across the floor with a 200 Newton force at an angle of 20 degrees slightly downwards. There's a coefficient of friction of 0.2 between the box and the floor. What is the acceleration of the box? There's 6 people in here who think this is an inclined plane problem. It is not. So this is on level ground. And I don't know where the inclined plane came from. So those of you who think that this was taking place on a ramp, I'm sorry, but from that point forward, it was very difficult to figure out what you were trying to accomplish. So somebody tell me a force that's acting on this box. Go ahead. Gravity, sure. So I'm going to draw a downward arrow. That represents gravity. I will label it clearly with the weight. I'm looking for labels. I'm looking for attention to this kind of detail. Go ahead. There's going to be a frictional force. Now, unfortunately, from this drawing, I don't know which direction to draw friction because I don't have anything here to indicate what direction the box is moving. So what direction do you think the box is moving, right or left? Okay, so if you think the box is moving to the right, then the frictional force would have to be parallel to the ground and going to the left. What else? Go ahead. So the pushing force is 200 newtons, slightly downwards. Okay. Anything else? Go ahead. Yes, there's a normal force from the ground pushing upwards on the box. There are a lot of people who don't have a normal force on their problem or on their paper, but it was in contact with the ground. There's no friction without a normal force. Now, I'll stop here because there's a whole bunch of people who don't have this picture. So take a look at yours. I have normal forces going off at angles. I have frictional forces that are lined up with the applied force and they're going off at an angle. Every one of these choices was made specifically because of the type of force it is and how it's applied to the box. Any questions? All right, I'm going to put together a coordinate system. I have to make choices about how I apply the coordinate system to the problem. But before I go any further, I didn't ask this from the beginning, but I thought it was somewhat obvious. Is this a first law problem or a second law problem? Has to be. It has to be. I'm asking for the acceleration, so we have to assume it's a second law problem. I believe it's going to slide across the ground, so I'm going to make this direction the positive x direction. And therefore from that, I'm going to make upwards the positive y direction. I see one force that is off axis and needs to be resolved. Do you guys agree? So I'm going to draw in two components that can stand for the off-axis force. The adjacent side will be 200 cosine 20, and the opposite side will be 200 sine 20. Any questions there? I see two forces in the x direction, and I see three forces in the y direction. I was looking for that specifically as well. Did you, after this, make a net force in the x direction and net force in the y direction expression? Right, there has to be one of each. And you had to set one of them to 0 and one of them to ma. So I'm looking for that too. In the x direction, there are two forces, 200 cosine 20 minus friction. I circled a lot of plus signs and minus signs for your direction. You have to pick a direction and then stick to it. If something's pointed in the opposite direction that you called positive, you have to make it negative. You're deciding the direction at this point. I have 3 uppy-downy forces, so one of them is up, and then 2 of them are down. Any questions here? Well, I don't know the acceleration, but I have everything I need to figure out the normal force. So I'm going to use that first. So solving for the normal force, I'll get mg, which is 50 times 10, minus 200 sine 20. So let's see. 432 newtons. Yeah. It would be plus 200. Thank you. So let's do the arithmetic correct, Mr. Shelton. 200. It's not even algebra. That's just bad arithmetic. So I get 568 newtons. Now, if I want to figure out the acceleration, I'm going to need the frictional force. I can figure out the frictional force right now because I have the normal force. Friction has to equal mu times the normal force. So that gives me a frictional force of 113.7 newtons. Now it's just some more arithmetic. So solving this for the acceleration, you'll get 1.48, I think, meters per second squared. That's what I'm looking for. I'm looking for a process. Okay?